Hi Level 3s and welcome to 3.6 Aqueous Chemistry. This is Lesson 11. Our learning objectives for today are to identify what reactions produce acid, acidic, basic and neutral salts, and to describe if a strong acid or base will conduct better. So here's a quick do now. So just to state if the following reactions are strong or the following are strong or weak acids or bases. So this is something you have to have memorized. So sulfuric acid is a strong acid, HBr is a strong acid, and aminomethane is a weak base. Hydrofluoric acid is a weak acid, NH3 is a weak base, and ethanoic acid is a weak acid. Write a definition of a conjugate acid-base pair. They differ by an H+ ion. So the first learning objective is to identify what type of salts are produced from various reactions. There are three types of salts that you have to be able to identify this year: a neutral salt, a basic salt, and an acidic salt. Now you'll recognise this equation here from your year 9 and 10 days. So acid plus base goes to salt plus water. And now we're just adding a bit more detail as to what type of salt is going to be produced. If you react a strong acid to a strong base, you get a neutral salt every time. If you react a weak acid to a strong base, because the weak acid produces a basic conjugate, which is what we went into last lesson, then the salt that is produced is in fact basic, and that's really important. So when you react a weak acid to a strong base, you get a basic salt, and the reason why it's basic is because this salt here, if it was to then react with water further, the water that's produced, what happens is that base accepts a proton from water and you end up producing hydroxide ions. So if we were to do this reaction, the result would be, instead of a neutral salt in water, would end up slightly basic, okay, because of these hydroxide ions. And if we react a weak base with a strong acid, so a weak base is a proton acceptor, it's going to take a proton here, and you end up producing the salt, which is acidic. So CH3NH3 plus is the conjugate acid of aminomethane, and it's weakly acidic. And so that means that it can further react with water to end up producing hydronium ions, and so the product's slightly acidic. So there are three types of salts that you have to deal with this year. If you react a strong acid to a strong base, you get a neutral salt, which means they won't react further with water, just neutral. If you react a weak acid to a strong base, you'll get a basic salt, and that means that that salt can further react with water, produce hydroxide ions, making the pH greater than 7, basic. If you have a weak base and a strong acid, it will always produce an acidic salt, okay, and those particles can further react, this salt can further react with water to produce hydronium ions, making it acidic. So here's a task. I'd like you to tell me the products that will form and the types of salts that will form. Okay, so pause the video now, give this a go. Okay, so the first task with nitric acid plus potassium hydroxide. So we know that the N switch, you keep potassium and you get nitrate from there, so you get potassium nitrate plus water. So I've done a symbol equation here. Okay, so the first thing you've got to identify is what is the type of acid and what is the type of base. So this is a strong acid and strong base, and because of that, that means that the salt that is produced is neutral. And so that means that it's not going to react further with water, so therefore the pH will be 7. The second reaction, methanoic acid plus potassium hydroxide, you get potassium methanoate and water, because you keep the first part of the base and the end of the acid. Methanoic acid is a weak acid, and potassium hydroxide is a strong base. So because it's a weak acid and strong base, the salt that you get is going to be a basic salt. Okay, so here's the symbol equation. It looks quite funny, H-cook. Okay, and then that salt can then, what I've done here is, if you're not aware, when you react an acid to a base, you get a salt plus water. Now, you will have done this at year 9 and 10. Once you've actually made that product, the salt and water, you can actually evaporate off the water and you're simply left with the solid salt. And that's what we actually do if we would like to add sodium hydroxide and HCl. You'd make sodium chloride and water. And if you evaporate off the water, you're left with sodium chloride, table salt. Well, it's the same thing here. So often you'll see, once the salt is produced, you'll see people break up that solid into the iron, so then they can further react the iron with water. This step is not really important. I just do it every time to make you guys realize that the salt that you produce, once the water's evaporated, it is solid. But technically speaking, because the salt is actually produced in liquid water, it would be aqueous. It's just a little additional step. So that methanoate ion can react with water to form methanoic acid and hydroxide ions, and these are basic particles, so therefore this is a basic salt, okay, because it's a conjugate base of a weak acid, and we know that conjugate bases of a weak acid are weakly basic, so it can further react to form hydroxide ions. The last example, ammonia and nitric acid. Ammonia is a weak base and nitric acid is a strong acid, which means that you get ammonium nitrate or ammonium plus nitrate, and so therefore this is going to be an acidic salt, okay, and so when that acidic salt breaks back up into ammonium ions and nitrate, the ammonium ions can react with water to produce hydronium ions. And again, this is reinforcing what we learned last lesson, that when you have the conjugate of a weak substance, it is weakly acidic or basic. So NH3, its conjugate acid, is weakly acidic. So I hope that makes sense. So, conductivity in chemistry. So we know to conduct electricity in chemistry, there need to be free-moving charged particles. Well, now that we've learnt about what different salts we can make and strong and weak acids and bases, we can actually start discussing one of the properties, a physical property of these, which is conductivity. So an electrolyte, as we know, is a solution that can conduct, because we've done that in redox, and so we can actually now compare whether things will conduct. In this first beaker, it's got sucrose. Sucrose is a type of sugar molecule. It's neutral, which means it's not an ion, which means that it won't conduct, and why we don't see the bulb go. Then we've got these various other solutions. Now, acetic acid is the same as ethanoic acid, which is a weak acid. Sodium chloride here we know is a neutral salt, okay, and hydrochloric acid, HCl, is a strong acid. So if we imagine these have all got, at least if we compare the ethanoic acid and the HCl, these would have been the same concentration, and if we compare the brightness of the bulbs between the ethanoic acid and hydrochloric acid, you can see the hydrochloric acid bulb is far brighter than the acetic acid. And the reason why, team, is because hydrochloric acid is a strong acid, which means that it completely breaks up into ions. So the HCl plus H2O forms Cl minus plus H2O plus, and so you get the maximum amount of ions present. So if there were 100 HCl molecules, as soon as they touch the water, you get 100 Cl minus and 100 hydronium, which gives a total of 200 ions, and so that's lots of ions, and therefore you get a high conductivity because ions are needed to conduct, and a nice bright bulb. Whereas so acetic acid, we know that acetic acid is a weak acid, so it's only going to partially dissociate, and the amount is unknown off the top of my head how much it dissociates, so I'm just going to make up a value. If we have 100 ethanoic acid molecules and only 20 of them form ions, that means that you end up with 80 of them left intact, which means instead of having a lot of ions, we've got very few. So we've only got a total of 40. So we do still get ions produced, but very little compared to the same concentration of HCl. And by concentration, I'm using 100 molecules to make it a little bit easier. So I'll just repeat that again. HCl is a strong acid, so it fully dissociates into Cl minus and H3O plus. So if we had 100 HCl molecules, that would make 100 Cl minus ions and 100 hydronium ions, which is a total of 200 ions, which is lots, and so it'll conduct really well, and we get a nice bright bulb. Now, if we have a solution, the same concentration of ethanoic acid's a weak acid, so partially dissociates. So if we start with 100 ethanoic acid, only about 20 of them would dissociate. So you'd only get 20 ethanoate and 20 hydronium, which is a total of 40 ions, which is much smaller, and so you'd actually get far less conductivity, and the bulb wouldn't shine as bright. So why does this neutral salt, sodium chloride, dissolve? Well, this is going back to just your purely thinking of ionic days. So sodium chloride being a salt, it'll it'll dissolve. So if you've got sodium chloride solid, it will break up into Na plus aqueous and Cl minus aqueous. And it doesn't matter if we've got hydronium or hydroxide ions, these are both still ions. So whatever the amount of sodium chlorides, let's say we had 100 sodium chlorides, you'd get 100 sodium ions and 100 chloride ions, so 200 ions. And that's why they would actually have the same conductivity. So if these were the same concentration, they would have the same conductivity because a salt completely breaks up into ions, and so you get the maximum amount of ions. So I hope that makes sense. So what is an electrolyte? Let's just go back and have some kind of perfect notes on this. An electrolyte is a solution which conducts electricity because it contains ions. And we know to conduct electricity there must be free moving charged particles, which can be ions or electrons. So electrolytes are made up of acid, bases or salts, because those are your particles that contain ions. So so therefore, like here you've got HCl, sodium hydroxide, sodium chloride. They will all conduct because they're made up of ions. So we've got two ways that we can classify electrolytes. So strong electrolytes are ones that conduct electricity very well, and that's because they've got a high concentration of ions. And so the way to get a high concentration of ions is by having strong acids or bases in there. And weak electrolytes do not conduct electricity very well because they have a very low concentration of ions, and these examples are weak acids and bases. Now I haven't included salts in these definitions, but we'll get back to salts in a second. Salts actually falls under this category, if I could spell salts properly, jeepers. But we'll come back to that. So this is just talking about acids and bases at the moment. So strong acids and bases are strong electrolytes, and weak acids and bases are weak electrolytes. Okay, and so here we can just see, again, it's just repeating if you've got a low concentration of ions, so that would be for a weak acid or weak base, that means that you'd have poor conductivity, the bulb wouldn't go bright, and if you have a strong acid and a strong base, you'd get a nice bright glowing bulb. So if we look here, dissociation of strong versus weak acids. So if you look here, HCl in a beaker completely breaks up into the ions. Now we know that H plus doesn't really exist, that should be H3O plus, but for the picture's sake, I think you're fine with it. And this is a weak acid, so this is H2CO3, and you can see here that this one breaks apart very little, so most of it remains intact and you get very few of the ions produced. So which one's going to conduct better if they've got the same concentration? Well, it's going to be the HCl because they've got a higher concentration of ions. Whenever we compare a strong versus weak acid, it's really important you understand that both of them have to have had the same concentration to start with so that we can compare. So if these had the same concentration, HCl would conduct better because it fully dissociates, producing a higher concentration of ions compared to this one here. Cool. So that's exactly what I've said here. So first of all, if you were to answer this question, you'd give a definition of conducting. So to conduct electricity, there must be free moving charged particles, ions or electrons. The higher the concentration of ions, the better the solution will conduct. HCl is a better conductor as it is a strong acid, therefore fully dissociates and donates all available H plus ions. Therefore there'll be 0.1 mole concentration of H0 plus and 0.1 mole concentration of Cl minus ions. H2CO3 is a weak acid, so will only partially dissociate, donating some of its ions. This means there'll be less than 0.1 mole of HCO3 minus and less of H3O plus. So that would be a perfect answer up to the highest level for that one. I hope that makes sense. Cool, so let's keep going. So task, are the following 1 mole solutions weak or strong electrolytes? So I'd love you to give this a go. So pause the video, give a go, and I'm going to answer now. Okay, so this is a strong acid, so it's going to be a strong electrolyte. This is a weak base, so it's going to be a weak electrolyte. This is a weak acid, so it's going to be a weak electrolyte. This is a weak acid, so it's going to be a weak electrolyte. This is a strong acid, so it's going to be a strong electrolyte. Also worth noting that this is diprotic, so it actually conduct better than HCl because HCl only has 1 proton, so you'd get twice the amount of H3O plus with this one here. NH3 is a weak base, so it would be a weak electrolyte, and KOH is a strong base, so it would be a strong electrolyte. So I hope this makes sense so far, team. I'll see you soon for part B of the video.